Hi, and welcome again to the InTouch Machine Edition training video series. This is the Drivers 2 video where you're going to learn a little bit more about details on how to configure drivers within InTouch Machine Edition. When you finish this course, you should be able to insert and configure drivers a little bit more detail than you did in the Drivers 1 video. You should also understand the details and the differences between the main driver sheet and the standard driver sheets. Notice I said sheets. Also, you should be able to use a tag for the station field, understand the scan and scaling. You should also understand the priorities of the reads and the writes in the different worksheets, know what virtual read groups and how to use those to help you troubleshoot, and talk a little bit about tag integration in this video as well. So let's get started. The InTouch Machine Edition has over 250 built-in drivers for all different kinds of devices, not just PLCs, but temperature controllers, drives, motion controllers, lots of different things that you would find in just about every field imaginable to control a machine, monitor temperatures, processes, things of that nature. There is no additional charge for these drivers, and one of the biggest things to realize about InTouch Machine Edition is that OPC is not required to communicate to an external controller. It's optional. We do support OPC. We support different flavors of OPC, but it's not required. One of the reasons why it's a good idea to use one of the built-in drivers is it's generally more efficient. Having direct communications with the devices instead of through OPC to that end device is often more efficient. So I'm going to pull in part of the help system, which is a diagram that I showed you in previous videos, where you have the tags database, the driver runtime, the TCP/IP server going to the viewer or the screens. What I've done is I've simplified that diagram here, so you'd have a screen here with the local viewer through the internal TCP/IP communications to the tags, whereas a driver or multiple drivers can have communications with external controllers. So that's the basic idea of what's happening. So what about this communications channel? This communications channel essentially exists of a physical layer and kind of a logical layer or a protocol. And so the different physical layers that we can have are serial, which could be RS-232, which is often a point-to-point connection, RS-485, which is more often than not a multi-drop type connection, and RS-485 can in general be longer distances than RS-232. You can have Ethernet connections. Those are probably more common ways to communicate to PLCs these days. And you can even have custom boards. So for example, Profibus, DeviceNet, and something we're still pretty good at, which is Data Highway Plus, Remote I/O, things of that nature. So depending on the different custom boards that we support in the various drivers, you can get at that too. And there's probably some other physical layers, but these are kind of the most common ones that we see. So we're going to get into configuring and talking specifically about what are the differences between the main driver sheet and the fact that you can have one and multiple standard driver sheets, and then you can have anywhere from 1 to 999,000. Notice that you're not required to use either one of these. You can have no main driver sheet and just standard driver sheets, or no standard driver sheets and just the main driver sheet if you want. You're really talking about having control over it a little bit. The triggering of the main driver sheet is really driven on a tag called blink slow, which is approximately 600 milliseconds. And in the standard driver sheets, you have separate triggers for read and write, and you have to control those manually. You have more control over the standard driver sheets, but the main driver sheet is a little bit easier to use. You have the same status fields, and here's where the differences really start to come in. In the header, or the top part of the driver sheet, it's really you can use any different file types or I/O types that are supported by the PLC. And in the standard driver sheet, per sheet, and again you can have multiple sheets, but per sheet you can only have one memory type or one I/O type, whether that be some type of holding register or inputs or outputs or coils, or depending on what the PLC supports, it's only one per sheet. So if you need to go to a different type and you're using standard driver sheets, then you're going to need to create another sheet. Whereas in the main driver sheet, you can put any and all in that driver sheet. So let me jump into the development environment here, which is right here, and then we'll talk a bit about, so for example, I've added a Modbus TCP worksheet in here, and by default you get the main driver sheet. Now let me go back and just remove this and show you how I did this. So what I have to do is go here to add remove drivers, and I'll remove this, and I'll just add one back in here. And I'm not sure if it'll keep my configuration, but here's what I did. I went to add remove drivers. I scrolled down, or easier is to hit the letter M on my keyboard. That jumps me down to the M's. And I know that Modbus TCP is just a little bit further down here, and then I'll select that or add that to my project. Remember that the number of drivers is not equal to the number of PLCs. You can have multiple PLCs per driver, so just FYI on that. So here I'm going to take the Modbus TCP and show you that the main driver sheet is by default installed for you, but yeah, just as I suspected, the previous configuration that I had was left there. That's a good thing. Let me delete that to show you how I configure this. So the main driver sheet lets you put multiple I/O types in here. This could be holding registers. This could be, if you're in an Allen Bradley world, it could be N7:0, and the next one could be a B3, and the next one could be an input. So you can mix and match those in the main driver sheet. If I add a standard driver sheet, and anytime I then insert after the main driver sheet, now I get the standard driver sheets, and they are numbered starting at 1. And they go up to 9,999. The differences here, again, like I was speaking on that chart, is on the main driver sheet, which I am here, you can put any addresses, and in the standard driver sheet, you have to put the starting address that you're going for here in the header, or this top part of this, and then you do offsets down in this address field. Notice here that the station or the PLC kind of IP address is up here in the header, and that's on a per worksheet basis, where in the main driver sheet you get to put a different station field if you wanted to here for any of the individual lines. And what I wanted to also point out is here in this station field, as well as in the standard driver sheets, you can use a string. So maybe you have a tag name called the PLC IP address. Instead of putting in an address, let's say for example 192.168.1.232, which is my PLC's address, and then 502, instead of doing that, let's see, we need a station 1 in there. What I could do is, instead of that, I could put in here curly brackets PLC station, and then I would have to define a string type tag, and then define the value of that somewhere in the program, probably typically in the startup script, and then I could use that. And I can use that idea here, or so let's make that a string tag, or in the station field here, and it would allow us to do that anywhere. So let's go back to that diagram a bit. Here we have the what actions we can read or write or read-write, and we can do that same thing in the standard driver sheet. And we have the same statuses. Let's see, station can be fixed or a string tag. That's what I just talked about. The scan, let's talk a bit about the scan here. The scan in the main driver sheet, or it's called the here scan, is you have the ability to set it up to screen, and if it's set to screen, it will only read or use that tag when it's on a screen that needs that information. If you go to a screen that doesn't have that particular tag, it will not bother reading that from the PLC. If you set it up to always, it will always read that in the background, so to speak, so that this is something you should choose if you're using alarming for that particular tag, or trending, or want to log it somewhere, so that that tag is always read, even if you're not on a screen, or even if you're on a screen that doesn't use that tag, so that happens in kind of the background. And the way that auto works is that it will start in kind of the screen mode until you get to a screen that has that particular tag, and then it will kind of jump into always mode and scan that, and it will stay in that always mode until you get to restart your application, where it'll start back over in kind of a screen mode, and until it needs it again. Then it'll kind of jump automatically into an always mode. So that's what the scan is there. You also have this action for, you can choose whether you want the tag to be read only, write only, or read write, both. Now this is again in the main driver sheet. In the standard driver sheet, you get to choose when you trigger the reads, when you trigger the writes, and how all that happens. So that's kind of your choice on how you do that. The main driver sheet is very easy, because you just put everything in here, and you just pretty much just say go. And then the standard driver sheet, you have to think about it a little bit more, but you get a little bit more flexibility and more power out of it. So let's talk a bit about here the scaling factor as well. Here I can put in a scaling factor, a division, and an add, and so I can do automatically scaling of, let's say, Celsius to Fahrenheit. I can do divide by 0.56 and add 32, and it'll convert from C to Fahrenheit, or vice versa, depending on how I want to do that. Or this is often used in analog, where you need to maybe convert 0 to 4096, coming back from a 12-bit analog, to some percentage or some value that's scaled for you, so it'll automatically take care of that. So let's go ahead, and what I'm going to do is I'm going to start up my HMI and get connected to that, and then configure some of these driver worksheets, and then start talking about the pros and cons. So I'm going to pause for a second, and I'll be just right back, and you probably won't even notice that I'm gone. So I'll be back once I have everything configured. All right, so I'm back, and so what I've done is I've got my remote HMI going. I've got a connection, a remote desktop connection to it. You can see here that I'm at address 3 on my network. So what I'm going to do is I'm going to go ahead and get rid of my standard driver sheet for a second here, and just in my main driver sheet I'm going to put in temperature. And I had configured that previously offline. I'm going to put in an address of 192.168.1.232 as the address of my PLC. I'm going to use port 502 and station number 1. And then I'm going to tie that to an address of 40,001, or 4x:1. Now that's going to go to my PLC and communicate, grab that value, and put it in the tag called temperature. I'm not going to do it for now unless I have problems, but I'm going to highly suggest that you use the status fields. I'm going to go ahead and save this, and then I'm going to go create a screen. And here I'm going to create a screen, and then I'm just going to put, let's say, a text display on the screen, and we'll call this temperature. And I'll just put some pound signs in here so I can get some values from a text data link. And again, I'm not expecting you to know how to do all this. We're going to cover more of this in the objects and shapes and animations videos. So I just want to show you here that the pound signs enabled me to put a text data link animation on this. This is a text object with a text data link animation, and here's where I can tie it to that tag called temperature. So now I should be able to save this screen, and we'll call this main. And I don't want to download that just yet. I want to make this the startup screen. And now what I'll do is I will connect up to this. I'm already connected. And then what I've done offline here is I've defined that I'm going to go into the projects folder. I made a folder called driver2. If you want to understand how to do a little bit more about this remote connection, take a look at the remote connection video. And here's what we'll do is, now that I'm in here, and I've already got some stuff in there, but I'm going to overwrite that. Folder's not empty. Are you sure? So yep, that's the place where I want to go. Now I'm going to download this project, so it's going to download the screens and the driver worksheet that I just made, and then I'm going to go ahead and run that. And I'm going to bring this in from off screen here, and what you should see is there my temperature is 41. I have that off on the PLC, just kind of counting up. In fact, what I'll do is I'll reset that back to 0 in the PLC, so you should see that go to 0. And so now I'm communicating. Now, some kind of troubleshooting that you can do, or status of what you can see what's going on. Let me go back to the development environment while that is still running, and I'm going to close this window even though it stays connected. Now, I don't have to be connected, but I can use this log win here, and I can go right to my device, which would be 192.168.1.3, and I can use the log win remotely, and I can tell it to go ahead and log field read commands. And you can see now that it's reading from that address, from that station, from that address. And I'm going to go ahead and pause this. I'm not sure where the pause is here. Pause right there. So you can see that I'm reading that from the PLC. Now what I wanted to talk about is contiguous addressing. And let's go back in here as this automatic calculation of block sizes and groups. Contiguous addressing is more efficient. So to talk a bit about this, the address, the PLC protocols, and most of them support this, is that multiple addresses read as a block of addresses are often more efficient than reading a bunch of individual addresses. There's overhead in the protocol that individual addresses are not as efficient as reading a block. So let's take, for example, if I take the same thing, I'm going to move this off screen and go back into my development environment. If I go back into my communications, my main driver sheet, and now let's say maybe I add pressure, and that doesn't exist. I'm going to keep that as an integer. I'm going to copy this, paste it down here, and now I'm going to go to address 4x colon, let's say 5. So notice that that's not contiguous. There's a gap. I'm not reading address 2, 3, or 4. When I save this and run this, let's see, I will call this back up over, let's see, offline here. Or did I close my window here? Let me get that going again. I'll be right back. All right, so I found that, but one of the things I forgot to do is now that I have pressure configured here, I need to show it on the screen. So I'm going to go back to the main screen. I'm going to copy this text object down. I'm going to change this tag to be pressure, and then I'm going to go back to the text, right, which I could do here or here, either way, and change this to be pressure. And now what I can do is save that screen, and now it's going to prompt me, do you want to download it? Well, yeah, I can download that. And what I should do is stop that and go ahead and run that again so all those changes take effect. And I'll pull that back on screen here. And why don't I have a tag there? Let's go take a look at 4x colon 5, that. Probably because I didn't save my driver sheet. So let's do that. Let's save that. Let's download it. Let's stop it again. Run it again. And let's bring that back on screen over here. There we go. So I just have some free running timers. In fact, all those addresses are containing the same value, but that truly is reading 40,001 and 40,005. And let's go back to the log win and unpause that for now. And you can see that when this catches up here, let's go ahead. Let's say it's not paused. Let's do field read and write commands. And you can see now that it's reading a block. Now let me pause this again. From 40,001 to 40,005. It's actually more efficient to read all 5 of those addresses as opposed to doing 5 individual addresses. So, and one more example along those lines. Let me take this off screen. Let me take that off screen. Let me go back into the driver worksheet and let's add just another one here. We'll call this level, and that doesn't exist. I'll copy this address here, and maybe I'll make this 4x:100 just to give myself a big enough gap there. And then I'll save this and I'll add it to my screen. So again, that was level, and so I don't make any mistakes, let me pull that from my list here. Level, go back to text, change this to level, and save this screen. And what I'll do is I'll stop my runtime from running. I'll download that so that everything takes effect. There are certain things that you can do that you don't have to stop it, but changing driver worksheets is one of them that you should stop it before you can see the effects of that. And we'll bring this back in here. And so now you can see those. Let me go make those something slightly different. So I'll take the first value here and set that to 1. I'll take the second value and set that to 50. And oops, it's the wrong address. I want 5. And so that should be this one here. So we'll set that to 50. And what was the other one that I did? 100. So that will be this one here, I believe. And we'll set that to 75. And apparently I got the wrong one, but you get the point. So now we see those as unique. But what I wanted to do is go back into the log win, unpause this, and tell it to log my field read and write commands. And then I'll pause this again for a second here. And now you can see that it's reading a block of those addresses and that one address. So to pay attention to how you have your addresses, the contiguous addresses, rather than having them all over the place at, let's say, 40,001, 100, 1,000, 10,000, it would be best to group them all within a close proximity or within the same block size, and that will depend on the protocol as well. So that's something to pay attention to, and that was a long process to show you contiguous addresses are more efficient. We talked about the always versus screen option of the main driver sheet. Now some things that, not really negative, but things to pay attention to are the fixed scan rate of the main driver sheet. It defaults to 600 milliseconds. You can change that default, and it shows you how to do that in the help system. Basically, you would create another tag with a different time base and then tell it to scan by using that tag. Every row requires a station configuration. Well, that may be a con to some people, but it's actually a benefit to others, where I can go to a different PLC if I wanted to. Every other line could be a different PLC, where if I went on the standard driver sheet, its entire worksheet is tied to that particular PLC. And if there's an error, the whole sheet has an error. So in the main driver sheet, if any address in this driver sheet has an error, the whole driver sheet has an error. So you're going to get a status in one of these fields that the whole thing has a problem. Well, how do you troubleshoot that? How do I know which address caused the problem? We'll talk a little bit about troubleshooting that towards the tail end of this video. Moving along, let's now talk about some of the pros and cons of the standard driver sheet. So if we go here, notice here we have these read and write triggers: enable read when idle, enable write on tag change. We're going to talk about those a lot here. So with the standard driver sheet, you really do have more control over the communications, and you get to choose when you read and when you write. You know, a lot of people will often, particularly in assembly or manufacturing, want to read faster than the 600 milliseconds. Well, you can do that, or some people will want to read or use tags slower. So for example, if in the middle of the night, let's say 2 a.m., you get a download from your production server that tells you when certain things are going to happen during that day. Well, you might want to only update that after that's been done at, let's say, 2:30 in the morning, so that that only happens once. You don't want that to continuously happen during the day. So you have control over that when you want those to read or update or write. The standard driver sheet can read constantly or on demand, and here's what I mean by that. You can set this tag here, or a constant, to enable read when idle. And if I put a tag in here that evaluates to true, or I just put the number 1 in here, this will read as fast as it can, essentially while it's running. Or alternatively, you can shut that off and read trigger. You can trigger when you want it to read. So you could tell this only when you want to read, or read on a consistent, you can read it on a consistent period here, or read as fast as you can. In a similar fashion, you get, let's see, we'll talk about that in a minute. So individual group communication feedback. So you have this same status idea that we had on the main driver sheet, but the main driver sheet, you put every different memory type in here. In the standard driver sheet, you really have one memory type, or file, or IO type in the PLC, and this worksheet will fail if there's a problem in that worksheet. So if you've got, let's say, inputs on one standard driver sheet, outputs on another, holding registers, maybe you've grouped things together for different modes, whatever. If that driver sheet fails, then you know that the problem is within the addressing on that particular sheet. Well, it's also really good to put statuses that have unique tags, and what I've seen a lot of people do is to make arrays for your statuses so that you can tell which worksheet is having a problem. Don't put the same read status in your main driver sheet and standard driver sheet 1, standard driver sheet 2. If you keep these statuses unique, then you'll be able to tell which one is causing you problems. So that's a good troubleshooting tip there. You can, let's see, so that's the individual communication feedback, one station configuration for the entire group. So it makes it kind of easy because you put the station in here. If you're only going to one PLC, which is often the case on a machine or a small process, you just have everything tied to one PLC anyway there. The cons is the configuration is less friendly than the main driver sheet. The main driver sheet, you just put everything in there and you don't have to pay attention to it. And one of the things you have to pay attention to is the block sizes in the standard driver sheets, because the main driver sheet handles all that for you. The standard driver sheets don't. So you really have to pay attention to here under the settings how the different block sizes match up for the different protocols that you have, and what address span you can use in there. So let's see, what else? Only one station per worksheet, unless you're using a tag in that case, and only one register type per worksheet. So again, you have to block those up kind of manually, and you have to pay attention to that. But it does lend itself to more flexibility. And you're going to probably end up using multiple worksheets. A little bit more difficult to maintain, but it is, again, a lot more flexible. So that's some of the pros and cons of the main driver sheet versus the standard driver sheet. Now let's talk a little bit about, in the standard driver sheet, you have these 4 fields here, and we're going to talk about the read trigger, the write trigger, the enable read, and the enable write on tag change, and we'll talk about those in a little bit more detail here. The read trigger, it's recommended when you want a specific read or want a constant reading rate. So you would put a tag in here that you would toggle, and you would cause it to read, as opposed to just happening at a particular scan frequency. You could tell that to happen once per day or once per hour, or whatever the case is, or just on demand when you wanted it. So you get to do that. And so the idea behind this word trigger, if you haven't heard me mention it in previous videos, is anytime that tag value changes. So it's not just from false to true, it's also from true to false, or it's any change. So it could go from 1 to 100, 100 to 101, 102 to 105. Just any change at all will cause that trigger to happen. And this is often used in reading recipes, PID parameters, or again, it's kind of an add as needed basis, so you get to tell it when to read. This has a higher priority than the enable read when idle, and I'll talk a bit about priorities in a slide a little bit later on. It shares the priority with the main driver sheet. And same thing here, as I'll show you priorities and how this all kind of gets together in a queue. The read when idle field is you use this when you want to have the fastest communications. Basically, you would put a tag in here that would evaluate to true, shut that off when you don't want to use it, or just put a constant tag in there, or just a constant number, I should say, and allow that to read as fast as it can. It does have a lower priority than the read trigger, but it does run constantly in the background. And idle basically means when the driver's not not writing or executing the read trigger fields. So again, we'll get into that when we start talking about priority. The write trigger field, it's recommended when you want to write several addresses at once, versus when you're using the enable write on tag change, that's used to write only a single address in the PLC. So here's the difference. When you use the write trigger, that triggers the entire worksheet to be written. If you use this field, the enable write on tag change, if an individual tag changes, it says, oh, I'm not going to do a block. I'm going to write just that individual tag the next chance that I get, or based on the priorities, as you'll see in a minute. But it updates that and only that tag, not the entire worksheet. So that's kind of the difference between those two. Each tag is going to cause a transmit message to be sent to the PLC. So it's going to block that tag up. And if you have multiple on a worksheet and you have enable write on tag change and 2 or 3 of those need to be written, it's going to do individual writes or transmits for each individual of those tags. So using the write status and write completed fields, you can tell if things were successful. So in the background, you can kind of get some knowledge of status of, okay, I tried to do this, did it happen? So that's some things that you can do there. I talked a bit about scaling using the divide and add, and conversely, if you want to multiply, you just do the division and multiply by the fraction, or divide by the fraction will give you the multiplication. And if you want to add versus subtract, you can subtract a negative number. So that's a couple different ways to do that. So here, let's talk about priority. And this is talking about the standard driver sheet versus the main driver sheet. And one of the things I didn't point out here is the increase priority checkbox. I don't want you to think that you can just check that on everything and it will help make things faster. In fact, that's probably not the case. The highest priority, and this kind of governs the queue of all the messages that go out to the PLC, the highest priority is a standard driver sheet with the increased priority checkbox checked. And then the kind of middle range is standard driver sheets using the write on tag change field. The main driver sheet using the write field are kind of equal. And then the lowest are these ones down here. If you choose to check the checkbox for increased priority, those messages, the priority messages, go into the driver queue and get executed, not in a first in, first out, but a highest priority. There's almost kind of 3 separate queues there, or buffers, and if there's only priority 1s, those will get executed. If there's priority 2s, also the priority 1s will get executed before the priority 2s. So this is what I was talking about. If, for example, you've increased your priority checkbox on all of your standard driver sheets, and you've got some main driver sheets that have read set up, if everything comes in with high priority on your standard driver sheets, you may never service the main driver sheets. So you have to be a little bit careful, as the increased priority can help maybe a small quantity of those, but it's really probably best to leave those alone, and you get to control when you want to read or write those, rather than letting the system configure those. But this is the kind of priority that those take. So again, just to summarize the different driver sheets, you can have one main driver sheet. Are you required to use it? No. You can have the standard driver sheets up to 9,999 of those. I'm sorry, up to 9,000. I'm sorry, start over. 9,999 of those. Are you required to use any of those? No. The maximum size, basically not limited except for up to 32,000 rows. The maximum size here is really determined by the driver. You get to control when you want it to read and write, whether it's enabled or disabled. Have the same status fields. The scaling can be done here. Now the triggering is, oops, I went ahead a slide here. The triggering or the scanning is based on always or screen, and in the standard driver sheet you get to figure out when you want to do that, and you can do your scaling for min and max or divide and add as well. So let's move out of the idea or the concept of using these driver sheets or drivers, and now let's talk about a concept of tag integration. What does this let us do? For a handful of protocols, we've implemented this thing called tag integration, where we can take right from the, let's say the export from the PLC, from the tags, and kind of work with those directly as opposed to adding everything into a sheet. And let me show you how we might configure that. So let me get out of this. And different from the communications tab and adding drivers in here, we would go into the project level and go to communications here. And at this point I can add a tag integration source. So I'm going to click on add, and here you can see the different providers that we have. We can support TwinCat, Codesys, RSLogix 5000, Allen Bradley PLC 5 or Slick 500, Automation Direct Koyo or the PAC 3000, and Schneider Unity Modbus. So those are the ones that we support currently. But let me give you an example of the RSLogix 5000 because I think that's what a lot of people are going to want to do. And I'm going to call this, let's say PLC 1, and click add. Now it lets me configure this. And here maybe I have a PLC address of, well, let's just use the one that I had. So I'll do 192.168.1.232, and the CPU is maybe in slot number 0. And now I need the L5K file or the RSLogix 5000 file. And so what I'm going to do is browse to that, and what I'll do is I will pull open an L5K file that I have here, and I will open that. And now when I click on OK, now it's added that as a source. Now where does that show up? If I go to put a bar graph on the screen, let's say, and here I've drawn a rectangle and I'm going to put a bar graph animation on it. Here now, instead of my system tags and my project tags that I've created, now I have this section called devices. And here you can see that I now have that PLC 1 that I created, and here's all the tags that are in that PLC export of that L5K file. Notice that they're kind of grayed out. Those are grayed out until I use them. So now I'm going to pick this bearing temperature, bearing 1 temperature, and I click on OK. And so now it ties right to that. I didn't have to configure the driver. It just it goes ahead and works in the background. And notice now next time I go in, you can see that that's been added to my project. And you can see that that has not added all those hundreds of tags. It's only added that one particular tag into my tag count. So let's now move along. Let's talk about troubleshooting. I talked about using logwin. It's very common that when you are connecting up to an Ethernet network to try to ping the device, one of the common things is you don't have a switch plugged in, or you don't have even a network connection to get to the PLC. So very easy to just try to ping the device. And a pretty common or a pretty nice tool, if you're not aware of this, is for example, if I do a ping of 192.168.1. So try to ping the PLC 232. You can see that I get the reply. It sends that out, and I get 4 total requests. But another tool or another nice thing is there's actually switches, so I can tell it -T here, and it will continue doing that until I tell it to stop with a Control-C. So I can maybe have this on my screen and have it reading, and I might be getting problems, and then I might be plugging and unplugging cables, and then when I see that I start to get these replies, then I know I have communication. So I can let this retry and retry and retry in the background and keep this on the screen. I don't have to keep typing that command over and over again, so that's a nice feature there. Most common errors are the wrong station number, port numbers, nodes. Take a look at the documentation. That often helps. Settings, obviously, if you're trying to go to a PLC that doesn't exist, or communication settings. I can tell you the number of days that I spent trying to chase down cabling problems or baud rates or things of that nature. Non-existing PLC addresses are very common too, especially tag names that are spelled incorrectly, or for example in let's say in a PLC 5, it's been a while since I've worked with that, but this will just give you an example. I think the PLC 5, for example, N7 addresses go from N70 to N7100 or something, and 101 and above don't exist until you've configured that in the PLC. So if you're trying to go to an address that doesn't exist in the PLC, you'll get an error. It's highly recommended that you use those status fields, and then as I mentioned previously in the video, use a unique address or possibly an array of addresses for each of those status fields in each of the different main driver, standard drivers, and then across the multiple standard driver sheets that you could have to help you try to troubleshoot. It's always a good idea to cut the problem in half. If you think you're having a problem in a particular sheet, maybe copy all the addresses out and paste those into Excel to hold on to those temporarily. Remove half of the line items and then try it again. See if the problem still exists. If it does, cut it in half until the problem goes away, until you can find out exactly which line caused the problem. You can do that fairly quickly and deduce what's causing your problem quickly. So let me take a quick look at my notes, make sure that I covered everything that I wanted to. And it looks like I did. So as always, for more resources, you can take a look at these parts of our website and see if you need more training, more information. And thank you for joining us in this video, and we hope you got something out of it. And join us for the next one. Thanks, and have a great day.